Okay, so first problem here. So this one's a little different because the ones we've been doing the last 2 days, there was only roots on one side. There was only a radical sign on one side, right? I'll give you an example. Here's the notes from Monday. On Monday, we only had a radical on one side, right? So we added 4 to both sides to isolate the radical, and then we went from there, right? Or they look like this here, right? Radical only on one side. Only one radical on one side. Today, they're going to be on both sides. Okay, we see on both sides. So we can't really isolate. How can you isolate them if there are multiple, right? If there's more than one, it's pretty hard to isolate. So today, isolate means one radical on one side, one radical on the other side of the equal sign. Okay, that's where my blue line is going to go. So when I say isolate, that's what I mean. Isolate on both sides. Okay. Okay. Square it, just like we did yesterday. Just like we did yesterday, I'm going to square both sides. Okay. When we do that, on the right side of the blue line, on the right side of the blue line, what is it going to be when I square a square root? X plus 6, right? Just like yesterday. On the right side, it's not going to be x plus 1. I can see a lot of you thinking, oh, it's just going to be x plus 1, right? It's separated, right? It's if this root right here kept going, you're right, it would be x plus 1. So if this was like this, it would be x plus 1. But because 1 is not included, it's separate. So it's 2 terms. So to multiply this, we're going to have to use a multiplication box. Okay, so we've done that before. So over here to the side, I'm going to do a multiplication box. Okay, so it's the square root of x and a positive 1 squared. So it's going to be times itself. Okay, I'm going to multiply like I've done before. We've done this part before. So the first thing, right? The first thing, if I multiply square root times a square root, I just multiply what's on the inside. So x times x makes the square root of x to the second power. So instead of having 1, I have 2 now because I multiplied them together. Okay, the next one is a positive 1 and a square root. I can't multiply 1 times x. I can't do that because 1's on the inside, 1's on the outside. So what do? I have a positive 1 on the outside, and x stays on the inside. 1 becomes the coefficient, and 1 becomes the radicand. Same thing over here. All right. And then the last one is just positive 1 times positive 1, which is just positive 1. Okay. Combine like terms. We always combine like terms if we can. So when I combine like terms, this guy and this guy are like terms. They both have the same root. So when I add roots, I just add the numbers in front. I don't change the root. So it's going to be the square root of x squared. When I add these two, it's going to be 2 square root of x. And then plus 1. Okay. All right. Now look at this guy here. What does this guy simplify to? just plain old x, right? The reason it simplifies down to plain old x is because this squared means there's 2 in there, right? Isn't there 2 in there? I'm looking for pairs, right? So that means one pair can come out, or one x can come out, and there leaves nothing left on the inside. So this guy here just simplifies to a regular x. Okay, got rid of that root. Okay, can I have your focus up here? Okay, so I don't have any x squareds. Oh, the other side too. Right, just all x's. So I don't have to do the rules I did yesterday, right? The rules are the trinomial rules. That's only if one of them squared. I don't have any squareds here. There are no squareds. Okay, so what I have to do is just get x on the same side. Okay, so to do that, I have to do the opposite, right? Because one's on one side, one's on the other. So I have to subtract it from both sides here. That goes away. They both actually disappear. Okay. So now what I want to do is I want to get x by itself. I want to get x by itself. So x is right here. Let me highlight it. I want to get that guy by itself. Everything around it, I want to get rid of it. So subtract 1 from both sides. Okay. Almost there. How do I get rid of that 2 in front? Divide. Yeah, I got to divide. Because the 2 is multiplying times the square root. It's 2 times the square root. So to do the opposite of that, I'm going to divide by 2. So when I divide by 2 over here, it just makes a giant 1. Because 2 divided by 2 just makes 1. Okay. 5 over 2. Now, 5 over 2 is a decimal. I'm not going to change it to a decimal. I'm going to leave it as a fraction. I can't reduce it. There's nothing. 2 doesn't go into 5 evenly. 2 goes into 2, but it doesn't go into 5 evenly. So there's nothing I can do to reduce it. So I'm going to leave it that way. I almost got x by itself. How do I get rid of the root? How do I get rid of the radical? Square it. Yeah, we did this earlier, right? Square it. Okay. So when I do that, I get x by itself. And how do you square a fraction? You just square the top. So what's 5 squared? 25. And what's 2 squared? Can I reduce that fraction? No, 2 doesn't go into 25. 4 doesn't go into 25. So yeah. So I'm going to leave it like that. Don't change it to a decimal. Leave it like that. Okay. Now, what do I have to do that some of you kind of got hung up on yesterday? To verify it. Yeah, verify if that's an answer. Some of you yesterday were like, Mr. Flores, I did my steps, but it's saying that both of these answers are wrong. So then I'm like, well, did you check them? And they're like, yeah, I did. But then, that was usually the mistake there. It wasn't the steps, it was checking them. Okay. So when we check, that's where you can change it to a decimal. So when I check, I'm going to change it to a decimal there because I'm going to use my calculator. And my calculator, it's a lot easier to use my calculator with decimals than it is fractions. So when I divide 25 into 4, I get 6.25. Okay. So I'm going to plug in 6.25 everywhere I see an x. So 6.25 plus 1 equals the square root of 6.25 plus 6. And I'm going to see if I get the same answer on the left side as I do on the right side. So now I'm going to get my calculator out. So what is the square root of 6.25? So if you get your calculator, most of your calculators look like this. So you hit 6.25 if you have a phone calculator anyway. 6.25, and then this button right here that I'm holding, 2.5. 2.5 times itself makes 6.25. And then over here, I have 6 plus 6.25. Okay, so I'm going to use my calculator again. So 2.5 plus 1 is 3.5. The square root of 12.25. 3.5. Checks out. They're both equal to each other. 25 over 4. So in Delta Math, I would put 25 over 4 into the box. One answer. Hit enter. Enter. Green check mark. Okay. All right. Okay, let's look at the next one. Let's look at number 2 on the inside. So anytime you have square roots on both sides, you're going to do what we do today. If you don't have square roots on both sides, you don't have to do what we did today. You're going to do what we did yesterday and on Monday. Okay, that we only do this when we have square roots on both sides. Okay, that's the time we have to do this. Okay, so I have square roots on both sides, so I'm going to square both sides just like I did the last one. Okay. So over here, again, if that -5 was underneath the square root, then it would just be x minus 5. But because it doesn't continue, x is just the only one under the root. Because of that, I'm going to do a table or a multiplication box over here. Okay. So I have square root of x minus 5, square root of x minus 5 times itself, right? Squared means times itself. Okay. So the first one is the square root of x times the square root of x. Well, they both have square roots, so I can multiply them. And when I multiply them, I get x to the second power. The next one, -5 doesn't have a square root, square root of x. I can't multiply them to make -5x. So how do I do it? I put a -5 in front, square root of x. Same thing over here. Okay. And then the last one's just positive 25. Okay. Okay. So now I have square root of x squared. These two are like terms here. These two right here are like terms. So I add the coefficient, I should say. So -5 plus -5 makes -10 square root x plus 25. This guy over here is the same thing we saw last time. Square root of x squared. That's got a pair, right? It's got a pair of x's. So it's going to simplify to x. Everything else moves down. Okay. Subtract x from both sides, just like I did the last time. They both go away. Positive 4. I want to get x by itself. Again, my goal is to get x by itself. So to get x by itself, I got to get rid of everything around it. So minus 25 now. So that makes a negative 21 over here. 4 minus 25 makes a negative 21. Okay. Divide by negative 10. When I divide by negative 10 over here, it makes a giant 1 because negative 10 divided by itself makes a 1. So I have the square root of x equals negative divided by a negative makes a positive over a positive. 21 over 10, I can't reduce that. There's no numbers. 2 goes in here, but I can't divide this by 2. Doesn't work. 3 goes in here, but 3 doesn't go into 10 evenly. 5 doesn't go into 21 evenly. There's no numbers that go into both evenly. So my last step, though, I have to get x by itself. I haven't got x by itself yet. So my last step is to square both sides, because that'll get x by itself. So 21 to the second power over 10 to the second power. 21 times 21 is 441. And then 100 times, or 10 times 10 is 100. Leave it as a decimal. Or sorry, as a fraction. Leave it as a fraction. Okay. My last step is to check the answer to see if it works, to see if it's an actual answer or if it's extraneous. So over here, I'm going to check it. That's when I'm going to change it to a decimal. I'm going to change 441 divided by 10. When you divide that by 10, you get 4.41. Okay. So then you go to your calculator and figure out what the square root of 441 is, or 4.41. 2.1. And then over here you get 8.41 when you add 4.41 and 4. So you add, it's like adding $4 and $4.41. You get $8.41. Then I got to take the square root of 8.41, sorry. Square root 8.41, square root 2.9. Positive 2.9. When I subtract this, I'm going to get a negative 2.9. Those aren't equal. They're close, but they're not equal. 2.9 is like I have $2.90 in my pocket. That's like saying that. Negative 2.9 is like saying I owe someone $2.91, or I just spent $2.90. Right? It's not the same thing. Okay. So because of that, this answer is extraneous. The only answer I got is extraneous. So what would I put as my answer? Empty box, right? Empty box. Yeah, some of you guys yesterday were like, I got two answers and I put them in and it's saying I got wrong. Well, when you checked them out, right? Turned out none of them worked, or maybe one of them worked, right? Empty box or just one answer. Or sometimes both of them work. You just don't know. Anytime you're dealing with roots and you're solving, you could have extraneous answers. Okay. Okay. Let's try. We got two more. Okay. So first thing, same thing. We got roots on both sides. Okay. So we have 3x plus 13. And then over here we can't multiply them again because you can't do the same thing. It's not going to be 4x minus 2 because this doesn't extend all the way over here. If it did, it would make our lives a lot easier, but it's not that. So we got to do a box. Okay. Square root of 4x minus 2 on both sides. When I multiply square root and square root, I can do that. I can multiply square root and square root. Square root here, square root here. I can multiply those. So when I multiply them, I get 4 times 4 is 16, and x times x is x to the second power. The next one I can't. The next one doesn't have this negative 2 doesn't have a root. So negative 2 is going to go in the front, and then square root 4x. Same thing there, same thing there. And then plus 4. Plus 4 because negative 2 times negative 2 is plus 4. Okay. Then I got to look for like common terms, like terms that I can combine. So this guy right here and this guy right here. So I get square root 16x squared minus 4x plus 4. Okay. I want you to look at this guy right here. What do you notice about that? It's not just x squared, right? If it was just x squared, we have an x, right? Well, we know x squared has a pair, right? So we can take out an x there. And what about 16? Right? Yeah, it has 16's on our list, right? 16 was on our list. So this guy we can take out as well. Square root of 16 is 4. All right, so that we can simplify a little bit. Okay. Do the same thing we did last time. Get x's on the same side. So to do that, I got to subtract 4x from both sides here. So I get negative 1x, bring everything else down. And then I got to subtract 4 from both sides. So I get negative 4 square root of 4x equals that. Okay. So when I got to this point on the last two problems, what did I do? What was my last step? What was my next step? Divide by negative 4, right? And I can do that. No problem. I can do that. But the problem is I have two terms over here, not one, right? So if I divide by negative 4, I got to divide that to make a fraction, and I got to divide that to make a fraction. I don't want to divide. I don't want to have to do that because then I make two fractions. So what I'm going to do instead is I'm going to do the next step after that. What was the next step after that? You remember? Square them, right? Square them. So when I square this guy, what is negative 4 squared? What's negative 4 times itself? 16, okay? So I'm going to have a 16 times, and then what happens to this guy when I square it? The root just goes away, right? So it just stays 4x. This guy, when I square it, it's got two terms. It's a binomial. So I got to do a multiplication box to the side over here. This one doesn't have any roots, so it's more like what we're used to doing. So negative 1 times negative 1 makes 1x squared. 9 times negative 1 makes negative 9x. Same thing over here. And then positive 81. Like terms. So I'm just going to write x squared because it's 1x squared plus 81. Yep, so we got a couple steps. We're going to do ABC, definitely, because we have squared. So we got to multiply this, so we get 64x here. So before we can do ABC, we got to set it equal to 0. That's our step here. We got to set it equal to 0. Negative 18 minus, I think it's 82. Now we can do ABC. So we got A equals 1, B equals negative 82, C equals negative 81. Wait, positive 81, sorry. So we got to find the two numbers that multiply to be 81, but add to be negative 82. There you go, negative 81 and negative 1. So it's x minus 81, x minus 1. So yeah, you're going to get two answers. Set those equal to 0, or you can do it in your head. What are the two answers that you get? Positive 81 and positive 1. All right. So my last step is I need to check them. check them to make sure to verify that they're both verified answers. Okay. You can do this in your head. You could do it on paper. It doesn't matter as long as you do it to make sure. Okay. So over here, I'm going to have square root of 4 times x, so 4 times 81, minus 2. 3 times 81 plus 13. Checking 81 first. So 4 times 81 is 324. 3 times 81 is 243. Okay. 324, the square root of 324, I believe, is 18. Minus 2 is 16. 256, the square root of 256 is also 16. 81 checks out. So 81 is a verified answer. So now you're going to do the same thing, except you're going to do that for 1, yeah. Minus 2. Okay, so I get square root of 4 minus 2 equals 3 plus 13, because 3 times 1 is 3. 2 minus 2. 0 equal 4. Nope. 1's extraneous. One is extraneous because when I plugged it back in, it gave me a wrong answer. 0 does not equal 4. Okay. All right. All right, we got one more. Okay. One more. Number 4 here. Okay, so same thing. I got square roots on both. I got radicals on both sides. So I got to square both sides. Okay, when I do that, over here, that's going to get rid of the square root. On the left side, it won't, though. It won't get rid of the square root because both of them are not under the square root. Only 8x is. Negative 2 is not under the square root. Okay. So over here, I got to do a multiplication box. Square root 8x minus 2. So you know what? I'm going to do it over here. Should do it over here, so it's close to the one that I'm doing it for. Square root of 8x minus 2. So I can multiply these two. These guys I can multiply since they're both square roots. So it's going to have a square root, and 8 times 8 is 64. X times x is x squared. Then negative 2 times the square root. I can't multiply those to make negative 16. So negative 2 goes in front. Square root 8x. Same thing down here. And then the last one is a positive 4 because negative 2 times negative 2 is just positive 4. I can combine the two that I highlighted because they both have the same square root. So I add the fronts. Negative 2 plus another negative 2 makes a negative 4. This guy here in the front, 64 is on my list. 64 is 8 times 8. So the square root of 64 is 8. And then x squared has a pair. So x can come out. Okay. Get x's on the same side, get numbers on the same side. So minus 8x from both sides. Minus 4 from both sides. Okay, so again, early on, I would divide by 4 here, right? Negative 4. But when I divide by negative 4, it's going to make fractions. So I'm going to do that later. So instead of that, I'm going to square it now, square both sides now. So when I square 16, negative 4 squared makes positive 16 times square root of 8x squared just gets rid of the 8x or the square root. Okay. And then this part over here is a binomial. So I have to set up a box for that. Okay, so I'm going to do that over here. This box right here doesn't have any square roots though. Okay. So we have negative 2x times negative 2x. That's a positive 4, x to the second power. I have a negative 2x and a negative 12. That's going to make 24x. I have a negative 2x and a negative 12. So that's going to make positive 24. And then the last one is negative 12 times negative 12, which is going to be positive 144. Combine like terms. Okay. Here we go. So multiply these guys here. 16 times 8x. 16 times 8 is 128. Is it 128? Yes. 128. Thank you. So before I can do ABC, I got to set them all equal to 0. I think it's 80. Okay. Now I can do ABC. Problem is, those are very big numbers. So if you're going to do ABC, I'm going to have to multiply 4 times 144. That's a huge number. So is there any way I can make those numbers smaller? GCF, yep. Can I divide them all by something? 4. Yep, 4 will divide them, make them smaller. So now 4 goes on the outside, so x to the second power. 4 goes into 80 20 times, negative 20 times. And 4 goes into 144 36 times. Now the numbers are a lot smaller. They're a lot easier to work with. They're a lot easier to work with now. So now I can do ABC. So A is 1. B is negative 20. C is 36. So multiplies to be 36, adds up to be negative 20. There you go. Negative 18 and negative 2. Good. Do I have to do bottoms up on this one? No, I don't have to because A is 1, right? A is 1. The old A originally was 4, but then I used GCF. So if you use GCF, your A is 1. So you don't have to do it. You can if you want, though, because you divide them by 1. They stay negative 18 and negative 1. So I'm going to get 2 answers. What are my answers going to be? Positive 18, positive 2. So my last step is to check them. Okay? Check them. So do that right now. Do that in the last 5 minutes. Do that. We'll tape them in our notes tomorrow. But I want you to check to see if both of them work, one of them work, none of them work. Which ones is it going to be? Because it could be the difference between a right answer and a wrong answer. Turns out they both work. 18 and 2 both are both work. Okay. All right, so we'll tape tomorrow. So just slide them in your notes, fold them, slide them in your notes so they don't lose. You don't lose them. But first thing tomorrow, I'll pass around the tape.